Hello, today we are working on our mission 3, which is writing and evaluating powers and exponents. So first, our definition, we're going to look at what is a perfect square. A perfect square is a number that is the square of an integer. And what we mean by square is that you're really multiplying the same number 2 times, which makes, if you're talking about area, the sides of a square. So for example, if I wanted to multiply 3 times 3, 3 times 3 would give us 9, or an area of 9. That's why we call it a square, because if we multiply them, that area would make a square. So these are what we call our perfect squares. They don't make rectangles, they make squares. So 1 times 1, we're going to use our multiplication table if we're not sure. 1 times 1 is 1. So we're going to write that down. Then 2 times 2, that's 2 times. 2 times 2 is really 4. Again, 2 times 2 is 4. Then we're going to do 3 times 3. If we follow those, we should get 9. 4 times 4 is 16. Maybe you know these first ones. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10, hopefully you know that one, that's 100. And then 11 times 11, this is where it starts to get tricky. 11 multiplied by 11 is 121. And then finally, 12 times 12 will give us 144. 144. So these numbers are what we call our perfect squares. I'm going to list them as just the number instead of writing it out 2 times. So those are our perfect squares. Now, to undo that, if I told you that the area of a square was 9, and I wanted to figure out what was each of the side lengths, what we'd have to do, which is called a square root. So a square root is basically asking you what number multiplied by itself gives you that number, 9. So if we looked at, I'm going to start somewhere in the middle here actually, at 16. What multiplied by itself gives you 16? Well, we know 4 times 4 is 16. So the answer, the square root of 16, what are all the side lengths? Well, every side would be 4. If we took the square root of 9, just like we have up here, what are the side lengths that make an area of 9? Well, 3, because 3 times 3 is 9. So we're really going backwards. We're looking for what's the square root of this number, and it will give us the number on the left, like 3. So let's take a look at a couple more. If we look at the square root of 1, what times what gives you 1? Well, 1 times 1 is 1. Same thing here with 4. The square root of 4, we know 2 times 2 is 4. So notice we have a pattern going on here. Then after 16, we have right here the square root of 25. Well, 5 times 5 would give you 25, so the square root of 25 is 5. What multiplies by itself to give you 36? Well, 6 times 6 is 36. Then 49, that would be 7, because 7 times 7 is 49. Then square root of 64 is 8, because 8 times 8 is 64. As you can see, we're just creating our pattern. These are our square roots. Square root of 81 is 9. Square root of 100 would be 10, because 10 times 10 is 100. Square root of 121 over here would be 11, because 11 times 11 is 121. And then finally, the square root of 144 is 12. These are our square roots of perfect squares. We're going to use these numbers to help us out. It might be helpful if on your multiplication chart you highlighted all of these ones in the diagonal, the yellow ones that I have here. We don't care right now about any of these other numbers. Please don't cross this off on yours. You might want them for multiplying. But right now we are only worried about these ones in the diagonal. those perfect squares. So let's look down at slide 2, evaluating the square root. It says, what is the square root of 36? You can either think in your head or look at our chart. We know 6 times 6 is 36. So the answer is 6. I'm going to go straight down here. We just have the negative square root of 64, so I know my answer is going to be negative. The square root of 64 right there is 8, because 8 times 8 is 64. Now over on the right side we have some fractions. We're going to treat them exactly the same as we would as a regular square root, except we can split it into 2. So we have the square root of 4 over 25, so we can write that as the square root of 4 over the square root of 25. So now we can simplify the numerator and the denominator. So the square root of 4 right here is 2, because 2 times 2 is 4. And then the square root of 25 is 5, because 5 times 5 is 25. So our answer, the square root of 4/25, is 2/5. Let's try the same thing on the second one. We're going to make it 2 square roots, the square root of 16 over the square root of 81. Well, the square root of 16 is really just 4. So there's 4, and the square root of 81, looking at your list, should be just 9. So your answer would be 4/9. Flip over to the back side. We are now evaluating or estimating between which two numbers is the given number located. So the given number would be this one right here, square root of 75. So if we look at our list, the square root of 75 is not actually on it. We have the square root of 64 and the square root of 81. The square root of 75 is kind of between these two. If I were to plug this into my calculator, it would give me some number between 8 and 9. It would be like 8 point something. Maybe like 8.4, 8.5. I'm not going to guess. We're not going to use a calculator. I just know where it's somewhere between 8 and 9. Or between the square root of 64 and the square root of 81. So I'm going to write down here, it's between the square root of 64 and the square root of 81. If we're looking at our multiplication table, same thing. It's between here and here. Only looking at the highlighted one. So we know the square root of 64 is really just 8, because 8 times 8 is 64. And the square root of 81 is really just 9. So our answer is between 8 and 9. That is really what it's asking for, because it said between which two numbers is the number located. It's between 8 and 9. So let's look for the square root of 35. 1, 4, 9, 16, 25, 35. Square root of 35 would be between the square root of 25 and the square root of 36. So it's between the square root of 25 and the square root of 36. So let's simplify both of those. The square root of 25 is 5. The square root of 36 is 6. So your answer is between 5 and 6. That means if we were to plug it in our calculator, it would tell us 5 point some decimal. Alright, let's look for the number 110. 110, I'm going to look at my multiplication table. 110, I see it over here, but this isn't on our highlighted list, so we don't care about those numbers, remember. It would be somewhere between these two, the square root of 100 and the square root of 121. So it's between the square root of 100 and 121. Write that down here. The square root of 100 is 10, because 10 times 10 is 100. And the square root of 121 is really just 11. So it's between 10 and 11. I would like you to try these bottom two on your own, and then click play to see if you got them right. So the square root of 10 is between the square root of 9 and the square root of 16. which is really between 3 and 4. And then the square root of 20, either looking at your list here or your multiplication table, 20 is between 16 and 25. Only looking at the highlighted numbers, not anything else, because we're only looking at multiplieds when numbers multiply by the same number, 4 times 4, because that makes a square, like our perfect squares. So the square root of 20 is between square root of 16 and square root of 25, which is really between 4 and 5. Alright, last page. This is our pencils ready. So I want you to simplify both on the left side, evaluating the square root, and between which two numbers is the given number located. So if we look at this first one, we have the square root of 25 over 121. I'm going to split that up into 2 square roots so it's easier to evaluate. We know the square root of 25. What times what is 25? Well, 5 times 5 is 25, so that simplifies there. And then the square root of 121, way down here, gives us 11. So our answer is 5/11ths. Down below, oh not down below, to the right here, we have a negative answer, negative square root of 49. Well, the square root of 49, right here, it's on our list, is really just 7. So your answer would be negative 7. And then just like we've been working, we want between which two numbers is the number located. It helps us to find out first which two square roots is it between, or perfect squares. So 12 on our list is between the square root of 9 and the square root of 16. 12, if we were counting, 9, 10, 11, 12, 13, 14, 15, 16. So it's between the square root of 9 and the square root of 16, which is really between which two numbers? Well, square root of 9 is really just 3, because 3 times 3 is 9, and the square root of 16 is really just 4. So it's between 3 and 4. Square root of 45. Let's find 45 on our list. 45 would go somewhere in between here. Square root of 45 is between 36 and 49, those two perfect squares. Between the square root of 36 and the square root of 49, which is really between 6 and 7. Now, one thing a lot of people get confused by is they try and think what numbers multiply to get 45. Well, we know that like 5 times 9 is 45. Well, and some of you are going to tell me the answer is between 5 and 9, and that would be incorrect because, first of all, those two numbers aren't next to each other on our number line. And we're looking for which two perfect squares is it between. Square roots and perfect squares go together. That's why we created this chart back here. They're opposites of each other. So in order to take the square root, you need to know what number multiplied by itself. And there is no number that multiplies by itself to give you 45. It's really between these two. 6 point something in our calculator multiplied by 6 point something in our calculator would give us 45. All right. If you have